Hi, my name is Yap Tyson, and today I would like to present my AI assignment. Okay, basically my project is to develop a deep learning model for satellite image classification. So first, we need to mount the Google Colab with the drive. Okay, after we mounting the Google Drive, so we need to import all the required module and package. So for example, NumPy and Pandas is for numerical operation and data manipulation. Then the MATLAB and the Seaborn is for data visualization. Okay, so scikit-learn is for splitting the dataset into training, testing, and validation dataset. Okay, as well as the computation matrix and classification report. For TensorFlow Keras is used for building the CNN model. Okay, after I import all the required package and modules, so I need to define the data path to the dataset. So here my dataset path is on my Google Drive. Okay, so after the after I define the path to the dataset, I need to load the dataset and pre-process the data. Here is the coding for loading my image, the dataset, and resize. I resize to 64 times 64 because I want to reduce the time required to execute. Okay, for faster processing and training. After I pre-process data, then next I display some sample image. For example, cloudy, desert, green area, and water. Later I will show the sample image. After that, I need to split the data into training, validation, and test sets. For example here, 70% is used for training set, and then for 30% is for the rest for training for validation and test sets. So here I split again the validation and test set into half. So it means 70% is for training, 15% is for validation, and 15% is for test sets. Okay. After that, we move to the data augmentation. Okay. Data augmentation is applied to the training sets to artificially expand the dataset and help the model generalize better. Okay. After the data augmentation, we move to the CNN module. I built the CNN model for simple CNN model because I want it for faster training. Okay. First, the CNN model is designed to be simple and efficient for faster training. So the architecture start with the first convolution block. It's with a system filter, okay, with the ReLU activation. So the block is followed by the batch normalization and max pooling, which reduce the spatial dimensions of the feature maps. Okay. For second convolution block, I use 32 filter. It's also use the ReLU activation and batch normalization and max pooling. After that, after the convolution layers, the features maps are flattened into a one-dimensional vector and pass through the dense layer of 64 neuron, and we're using the ReLU activation. So the dropout 0.5% is to prevent the overfitting. Okay, finally the output layer use the softmax activation to provide a probability distribution over the classes with the number of neurons equal to the number of categories. After that, I compile the model with Adam optimizer and sparse categorical cross-entropy loss. After I compile the model, I need to train the model. But here I only use the hand epoch because I want it for faster training. After that, here I need to evaluate the model on the validation set. Then after it validate the model, it will print the validation loss and validation accuracy. So here is for visualize training history. So it will plot two graphs for accuracy over epoch and loss over epoch. After that, it will also print the classification report and display the confusion matrix using a heat map. Okay, then finally we can visualize a few sample prediction for the test set. Okay, so for example, here displaying some sample image for cloudy categories is from my dataset. So it's cloudy, desert, green area, and water categories. Then after that, after training for 10 epoch, it will display the validation loss is 0.2139 and validation accuracy is 0.8923. So this is the graph, the accuracy over epoch and loss over epoch. So the higher the epoch, the accuracy is become better. Higher number of epoch, it will reduce the loss will reduce. Okay, for this is the classification report. It show the model accuracy is 89%. Okay, so this is the confusion matrix. For water is correctly predicted 175 and is misclassified as green area for 46. For cloudy, 191 is successfully classified as cloudy, but 32 is misclassified as desert. For green area, it's not misclassified, it's all correct. For desert is 165 is correctly classified as desert and 5% misclassified as cloudy. This is the sample visualization. For example, the color is true is cloudy and is successfully predicted the cloudy. For green area, true is green area is successfully predicted as green area. Here, the true is water and is misclassified as cloudy. And this one, the true is desert and successfully classified desert. And for here is the truth is cloudy and is successfully predicted as cloudy. That's all from me. Thank you.